So this next idea is an underlying concept in hypothesis tests. However, it's not something we will actively discuss during each of the tests that we do throughout the problems. It's the idea of whether or not you make the right decision at the end of the test. So in running a hypothesis test, as we'll see more of on the next pages and next sections, your ultimate decision is one of two things. You're going to collect that data, run it through our computations, and decide to either reject the null, meaning we found evidence very strong to support the alternative, so evidence against the null being correct, so you will reject the null, or our evidence isn't strong enough, and so then we say, well, then we won't reject the null. I want to kind of specify that, and we'll see it again, that we don't say accept the null. It's either reject the null or do not reject the null, kind of a double negative that would imply accepting in a sense, but think of it more as we're sticking with it because we didn't disprove it. That's the idea of not rejecting. So those are the two options. But the question is whether or not you make the right decision, because just like confidence intervals last chapter, we're not going to make a 100% confidence interval because it would be so wide, it would be pointless to have made in the first place. So kind of the same thing here. We have to allow ourselves some room for error, otherwise we'll never end up rejecting any of the nulls because the requirements would be too extreme. So we leave ourselves a small room for error, and so in that sense, it's always possible that the wrong decision gets made because you're only using a sample to determine something about a population. So there's room for error. So the idea here, like I said, the test will result in either it's rejecting or not rejecting. The question is whether it's the right decision. Well, if you reject the null, if our test says reject the null, and it turns out that the alternative was actually correct, well, then we've made the right decision. We've rejected the original, and we're supporting, right? We found the evidence that we're saying supports the alternative, and in this case, we're saying that would be true, which would be the right decision. Or if we run our evidence through the test, and it's not very strong evidence, and we say, okay, well, then let's not reject the null, and that's what we're saying, and in reality, it turns out the null is actually correct. Well, now again, we've chosen to not reject something that is true. Well, that would be also, again, the right decision. You didn't dismiss the true thing. Again, you don't know these. You never know what the actual reality of the null and alternative being true or false is. But again, we're trying to limit the chance of making mistakes. So these are good. But if you run a test where your evidence says you should reject the null, but it turns out the null is actually true, that would be a mistake, right? We wouldn't want that to happen very often, hopefully. And so that is referred to as a type 1 error, making that mistake. Now, the other mistake would be running a sample through and the evidence not being very strong, so we say we can't reject the null, but it turns out, in reality, the alternative was true. Maybe our sample just wasn't a good representation and didn't give us the evidence to that effect. Well, again, if you've said we're going to not reject the null, we're going to stick with the null when we shouldn't have, right, when the alternative was actually correct, that also is a mistake. We classify that as a type 2 error. So to summarize all that up in just a quick visual, I think this kind of helps. We're going to make a small box here, just big enough to write a couple words in, actually very few words. And so think of it as this. Think of it as the two options for a test are, again, to either reject the null or not reject the null. That's the only two possible options at the end of a test. And the two possible scenarios are that null hypothesis is true or it's false. Now again, with us saying this, that's like us saying the alternative is the true one, is the correct. So H sub 1 is true. So if you were to reject the null and it turns out to be true, that's like this third one up here, rejecting the null when it's actually correct. That is called, again, a type 1 error. We don't want to do that. But if you reject the null when it's actually a false statement, then you've done the right thing. Similar, if you have a null hypothesis that's true and your test tells you to do not reject it. Well, good. We don't want to reject something that's true. That would be a good decision. But lastly, if the null hypothesis is false, but our test says, stick with it, don't reject it, we've made a mistake. We don't want to stick with something that's wrong, and that's referred to as the type 2 error. So, of those two errors, as we're going to find out, the type 1 error is the one we want to limit. We want to specifically conduct our tests to avoid this, I'll say, as much as possible or a certain percentage of the time. We really do not want to reject something that's true, okay? So, going down here, first of all, jumping down to the bottom, just to point out, we've got these Greek letters alpha and beta to represent the probability of allowing a type 1 error or type 2 error to occur, although we do not deal with beta at all. We focus our hypothesis tests solely on alpha, solely on the chance of making a type 1 error, okay? Now, in this situation from earlier, the mean length of phone call studies, the interpretation of the type 1 and type 2 error. So remember, in this case, the null was that it was 3.25, and the alternative was that it was increased, right, larger than 3.25. So in this case, the type 1 error would have occurred if our evidence, if our sample told us to conclude that it was larger when in fact the mean was actually 3.25, right? This would be the null was true, but we supported the alternative. That would be a mistake, right? And again, that's the one we want to avoid. The type 2 error would be if we had stuck with the mean being 3.25 when actually it was larger. That would be the other wrong decision from our hypothesis test. That would be a type 2 error. But again, we're going to focus on alpha and a type 1 error as the thing we try to limit specifically. Now, that level that we allow ourselves, room for error, is referred to as the level of significance of the test. And there's again alpha. So the probability of making a type 1 error is called the level of significance. Okay? Interestingly enough, as you increase that type of error, the chance of creating a type 2 error actually decreases. So these are inversely related. But let's take a look now at that final statement we're going to make about the hypothesis test. So again, we've left out almost all the middle of this test, all the meat, all the calculations and comparisons and why we make decisions. That differs based on the section we're in. But this idea of how you summarize your test is what's important. And it basically goes back to that statement I mentioned earlier. When you're talking about these hypotheses, the only two options you have are that you're going to reject the null or not reject the null, okay? And so because of that, the statements, as we get to what I'll call kind of the sentences or the big sentence that we write in an answer, we either will say, if we're rejecting the null, we're saying we have sufficient evidence to support the claim. Now the claim, that is always going to be essentially the word version, right? The written out version of the alternative, what we claim, what we were claiming or trying to prove. But if we run our test and the evidence is not strong and we don't reject the null, like I said, we're not going to say there's sufficient evidence to support the null. We're just going to say there was not sufficient evidence to support our claim. So rejecting the null means we can support it, but not rejecting the null means we can't support that statement we were trying to test. So a couple examples here, or one example, both situations. Again, with our mean length of phone call. Suppose the sample evidence indicates the null hypothesis should be rejected. State the wording of the conclusion. Okay, so just focusing on that wording up there, we would say, if we're going to reject the null, right, rejecting the null hypothesis, we would say there is sufficient evidence to support the claim. And like I said, you're just putting this back into words. This statement up here regarding the population mean. That the population mean length of a cell phone call is, you could say, has increased, or specifically I could even say is greater than 3.25 minutes, because that is what we think it's increased from. Oops, that's not straight at all. So the evidence is there's sufficient evidence to support the claim that the population mean length of a cell phone call is greater than 3.25 minutes. We are saying we have the evidence to support what the researcher believed. And if we ran a test where we decided the null hypothesis could not be rejected, it's going to literally be this exact same sentence except we throw the word not in there. If I want to write it out just to show you that is the only difference. We do not rephrase anything. We just say, because of this, we do not have, there is not sufficient evidence to support the claim. That the population mean length of a cell phone call is greater than 3.25 minutes. And I realize that's horrible handwriting, but that's why I said it out loud.